and welcome to Wildly Curious, where the questions are unhinged, the science is real, and honestly, we're just getting started. I'm Laura.
And I'm Katy. And...
Ever wonder why a bat might glow? Or how frogs made it to space long ago? Dinosaurs trained for delivery runs. We're asking the questions, the weird ones. Wildly curious, where science gets strange and kinda hilarious. For nature's wonders to ancient funk, it's facts and fun rolled into one big chunk. Wildly curious, weird is wonderful. Come join the fuss.
All right, we are back for number three.
Number three.
Of our Nature's Mysteries. And so my first one with the moon, that's borderline mystery. Because again, I just wanted to point it out because
I don't think people think about it.
It's hypothesis,
Yeah.
right? That's the beauty of science. We are constantly coming up with new theories for things.
Yeah.
This one is a little bit actually more mysterious than the moon one. I've never even heard of this, but as soon as I looked it up, I was like, ooh, I'm invested. And I spent 2 hours researching this episode because there's so many scientific papers written about this.
Interesting.
But with very little...
Yeah.
So it's called the Hessdalen Lights.
Oh, yeah.
Yeah, I'd never heard of this before.
I know about this one.
So
but again, I was a hardcore...
Yeah,
I was the middle schooler
this is the
who...
weird stuff.
Yeah, I was the middle schooler who was like, I'd be totally okay being abducted by aliens. As long as there was no pain involved, I'd be okay with it.
Well, for anyone who hasn't heard about it, the Hessdalen Lights are what is called an atmospheric luminous phenomena.
Ooh.
I like that. Love that. That occurs in the Hessdalen Valley of central Norway. So these lights can take a lot of different forms, but mostly they're balls of light varying sizes and colors. They could be anywhere from decimeters, so to 30 meters in size.
You know,
so
there's ones here in Texas too.
Oh, cool.
Yeah, down by Big Bend. Very similar.
They can pulse. They have erratic movements. There is sometimes intense emissions of energy. And sometimes they can even last for a while. It's not just like a blink gone. It's like a little bit.
Yeah. Hey, I know that my eyes aren't playing tricks on me. It's been, I'm looking at this long enough kind of thing. Yeah.
And so there's 4 main types. Type 1 are blue or white flashes that last about 2 seconds, occurring in all weather conditions. Type 2, mostly yellow, of various shapes, lasting from minutes to hours, and they can be stationary or moving. Sometimes split and send beams out. Type 3, multiple lights...
Wait, hang on. Pause for 1 second. So is it consistent? Did you say the first one, how long those ones last?
That's 2 seconds.
So it's interesting that it's...
to hours, to
but it's color-coded. You know what I mean?
That's true.
Yeah.
The third type is that there seems to be multiple lights attached to a single object. And then type 4... can be different shapes rather than just like the ball shape, like cigar shaped or saucer.
Oh my god, there's a triangle coming at me.
Giant. That would be weird. They can also be seen way up in the sky or really close to the ground. So yes, there's consistency, but also like you never know what the lights are going to be tonight, guys.
Yeah.
So people have been observing them since the 1800s, which I thought was kind of interesting that it wasn't before that even.
Yeah.
I mean, maybe it was.
Wait, did you say it was one place in Norway?
It's this valley, this Hessdalen
valley.
Valley.
Okay.
Yeah. So you can see it between these. It's a pretty wide viewpoint.
Yeah.
But again, the fact that this hasn't been happening like forever.
Yeah, interesting.
Or,
because stories like that get passed down over time. You know what I mean?
You would think that this would be on cave art, or you know what I mean? Like this would be freaking weird.
Or just talked about, like for passed down from generation. Oh yeah, this is. They might not have any written records of it or like evidence or anything, but it has been talked about. Yeah, it's interesting that 1800s.
So maybe that is just all I could find, but it's been longer. But everything started to come to a head in the 80s when everybody was, we're gonna dive into the crazy. We're trying to uncover these mysteries.
Yeah.
So in 1984, Project Hessdalen was begun, and it was 36 days of observation using tools to measure. They used radar, magnetometers, radio spectrum analyzers, seismographs, cameras, Geiger counters, infrared viewers, and lasers.
They're like, bring it all.
Throw it at it.
Yeah, bring it all.
We're going to figure this out.
Yeah.
So
for them to put that much effort into it, that it's consistently around, because if it was just every so often that this anomaly happens, but no, they
figured they could get enough data in 36 days.
Yeah, that's insane.
Like, it's happening a lot.
Yeah, that's insane.
And so with all of these things, this was basically the first time it was scientifically studied.
Yeah.
This showed that the phenomena was measurable, especially by radar, radio spectrum analyzers, and magnetometers. The rest of the stuff was like, not really. It's nothing from the Geiger counter or stuff like that. But with the radar, they could see some stuff.
Yeah.
With the radio stuff and with magnet. So there were during that 36 days, there were 53 visually witnessed occurrences that were recorded, where all the recordings happened for those 53 times. They seem to occur at the same time, or at that time anyway, during that study, they seem to occur at the same time as some kind of magnetic perturbation. Something weird with magnet stuff happened around.
But how does the magnets cause light?
Right. So there were some weird things, though. As a scientist, it'd be so cool.
Yeah.
But also, what the heck? The person who kind of wants to believe in magic of me would be like, I knew it! So, peculiar radar behavior was observed. For example, you might visually see that they could visually see some of those lights, and they did not show up on radar.
Yeah, happens for depending on what it is.
Yeah. So, and then, they would move insanely fast.
Yeah.
As in, they looked almost like they were appearing from one spot to the other, but it was just erratic movement because they were going so fast.
Aliens, man.
Yeah. There were spikes in high-frequency radio signals whenever they occurred.
Aliens. And teeny tiny ships.
Yeah.
And then, really little.
Or 30 meters, yeah.
Yeah.
And then when they would shine lasers at these lights, which also seems like I would have been freaked out to shine a laser at something that I didn't know what it was yet.
Yeah.
Well, sometimes the laser, so you know how I said these lights would flash or pulse?
Uh-huh.
When you shot a laser at it, it caused them to double flash until the laser was removed, so they knew it was interacting with the laser.
What the heck?
Yeah. So I would have been like, guys, stop pointing it at it.
Yeah, there is...
It's got to be something with the refraction, but I would have been like, aliens.
Yeah. At that point, I would have been, I feel like it knows.
And then we're shining this light at it.
Yeah.
So that was 1984. There was an international physics workshop in 1994 that tried to workshop a lot of the theories that was coming out of this research. Can you even imagine, too? An international physics conference and then them workshopping
this
high-level talk.
Yeah, but again, then clearly they had enough evidence that something is going on for them to workshop it through with a bunch of scientists to be like...
Yeah, they were just taking and looking at all the data.
Yeah, there's a ton of data here that's showing anomalies. Somebody's got to have some ideas. Let's put it in front of a bunch of scientists who can figure it out. That's crazy. Yeah.
And then, so they had some theories that came out of that. But then in 1998, so 4 years later, they set up the Automatic Measurement Station, which has been in use since 1998. And it just had less tools, but it had the tools that they knew mattered. It had cameras this time because now we have really good cameras.
Yeah.
It has radar and it has magnetometers on it. So it's just constantly recording.
Yeah.
And so data has been coming out of that. We know now that the lights are more frequent in the wintertime and often occur between 10 p.m. and 1 a.m.
Interesting.
So there's higher humidity in the winter, so it seems to maybe be correlated with humidity.
Which is weird because if it's a light and if it's anything like static, you would think it'd be less humidity.
Right.
Because the winter, everything dries out. And I couldn't even touch a shopping cart up north in the winter because it would be so static,
But I guess maybe Norway's different with it, because of the precipitation. I don't know.
Maybe, yeah. Interesting.
And then 2 years later, in 2000, it was equipped with automated radio instruments for about 1 month just to see what it could get. But, okay, then I was like, I gotta synthesize this data somehow because this is a lot.
Yeah.
Okay, what they found from both Project Hessdalen and this automated stuff, here's some bullet point stuff. 1, no preferential trajectories. They're moving willy-nilly all over the place.
Okay.
A lot of times jerky movements over short distances, which almost looks like instantaneous movement.
Okay.
Like I said, a lot seen during high humidity. The light phenomena is always preceded by a very short-lasting flash of light, which could appear anywhere in the valley, ranging from 10 to 300 watts. The intensity of the light balls, which, if you can really see it in good conditions, is 3D in shape. Like, it really looks 3D. It produces light with a constant color temperature. And this, you're like, well, so what? But that means the energy isn't changing. It's on or it's off. It is not changing in its color.
Huh. Yeah.
So it's not burning something.
Yeah.
So anyway, it seems like. It has a very strong infrared signal, which makes sense because of energy.
Yeah.
And it is suspected that it is releasing round iron particles onto the ground. Like, iron is raining down.
It's all the leftover stuff from the moon. That's where it all came from. Right.
So then I was like, Lord, okay, so what do they think this even is? There are 4 different models.
Okay.
I had Chatbot help me synthesize this, but I'm not going to go into too much detail because it's a lot of science. But 1 could be an electrochemical model of ball lightning, which we have talked about ball lightning before on here and how weird it is. Yep. And it is pretty unexplained. But basically, that the fact that it's electrochemical here is like the key word.
Yeah,
so like
yeah.
It is hot plasma, and as air is moving around it, it actually turns it into a circle, solid-like object.
Yeah.
And it would explain the pulses, it would explain the clustering, it would explain that it could last for a long time.
But
how does it form?
Yeah.
It's still not really explained.
Yeah.
How that happens.
Interesting.
So then some people are like, okay, what if you combine some theories? It is electrochemical ball lightning, but what starts it? Maybe that there is a lot of quartz, iron, and I think that they said copper and zinc in the ground.
Mm-hmm.
And as tectonic plates move, they create stress, which can create friction, which can create electricity.
Yeah.
So if it can ignite something, then the electrochemical reactions take over and it becomes this ball lightning. So it's actually the ground's electricity that's forming the balls, which is why some are close to the ground. And
But does it move fast enough to cause that? You know what I mean? There would have to be like tiny earthquakes.
You'd think so.
Didn't you say that they used the seismographs? Like they had didn't you say that they
did have seismographs? But I guess it wasn't enough that it's right, like earthquakes.
Yeah. Yeah, because they certainly,
also,
they can pick up a lot, but it's not going to pick up if it's real slow vibrations.
Yeah. The oldest theories, which they've basically are like, this is probably not it, is that it's solar or magnetic, so solar storms. Like the Aurora Borealis explanation doesn't seem to be that. Yeah. There's too much going on here. Mm-hmm. And there's actually not that much of a correlation between sunspots and these lights. Like, there's no correlation that's been shown. And then last one is the Abrahamson and Dennis model, which says that very strong electrical discharges can vaporize silica, heat it and glow, and maybe they could form sphere-like objects. But
the movement is what gets me. You know what I mean? The moving of it, because the lightning, could explain that, but I don't know. The lightning one doesn't quite sit right with me. The last one, the silicon one that you said, that sits a little bit better, but at the same time, that doesn't really explain why it would move. Yeah.
So, and there's 2 different things. There's basically like ball lightning, which happens in the sky, and then there's what they call earth lights, which are also plasma, but coming from the ground. So some hypotheses are like it's naturally luminous stuff that arises in our atmosphere. But they don't know why. So it's like the cop-out. It's, okay, I mean, maybe it's just earth lights. Yeah, but what's an earth light?
Yeah,
And how does it form this very specific geometric ball?
Yeah.
So I do think it's probably ball lightning, but we obviously know nothing about this stuff.
Yeah, there's something else going on that's causing it to be this predictable and this consistent.
And at the same time, this erratic.
Yeah.
Like, it is.
Consistently erratic is the only consistency.
We know, lightning sure looks different, but guess what? It's always coming from the sky or from the ground or the cloud. Like, we know about lightning. Now, this plasma stuff, it is still pretty unknown, and the electrochemical part is weird because it's not burning anything, kind of. It's just burning itself. And it definitely explains the sphere. It's just right. It's the movement, and then how does it ignite? Because it needs some kind of ignition.
It needs something, to start it. So and like you said, unless it's a combination of
multiple things.
Yeah.
And then, of course, Oh, go ahead.
Oh, no, I was just going to say, this is one of those ones where it's like I knew about it as a kid, reading about it, but then...
it's freaking complicated.
Yeah, it is very complicated. And then you become an adult and it's, oh, yeah, pull, that from that memory, but then you never really dive into the science and how science is...
Yeah, it's amazing. Like, I need Neil deGrasse Tyson to explain this one to me because I feel like he could do a better job synthesizing it to me. So you can look up Project Hessdalen, and they have a website. They're constantly releasing data. It's an active website.
Yeah.
And then scientists have written research papers synthesizing this data that are free. I didn't have to go through any paywalls to find them, which was great.
Which is nice, yeah.
So yeah, definitely check it out if you're into physics, or this is a pretty weird mystery because, of course, some people are, it's the military or aliens.
Listen, I will say aliens before the military, and the military has already admitted that there is freaking aliens, but all the other bullshit that's going on right now, we can't focus on the aliens because
there are aliens.
Chaos is happening. This would be a time I'd be okay with being abducted. I just got a kid, so just let's make sure he's taken care of. But like,
so the Hessdalen Lights, an unexplained natural phenomena that I do think that we will find an answer for eventually, but it's going to take a lot more research, and it's just so niche.
Oh, yeah.
I bet there's not a lot of funding behind. You know what I mean?
Right,
like, it's like, people want to know, but like, how much work are we going to put into this?
Yeah. That makes sense. All right, guys, that's the third one. We have one more week. We're going to do these minisodes, and then we're going to kick off season 13. So make sure you go follow us on social media, support us on Patreon if you can. And until next week, we'll talk to you, I guess, on social media between now and then.
Later.
To space long ago, dinosaurs trained for delivery runs. We're asking the questions, the weird ones. Why?